Okay. All right. Thanks, everyone, for having me here. So I wanted to talk you through some of the announcements coming tomorrow. There's quite a few announcements, but in particular, I think the one that's going to be exciting for all of us is really the talk about Docker Enterprise Edition and the integration with Kubernetes. Before I jump into that, I thought I'll spend a little bit of time on the Docker platform and what all the pieces are that make up this platform, so you have a better sense of how this fits into the overall story, and how this really impacts customers and users of Docker. So I'll start with a quick overview of kind of the overall platform, and I'll speed through some of the components, which obviously there are actually tons of videos and tons of information out there about each of these individual components that we can dive into, and we can always take questions afterwards. Operating systems and infrastructure, you guys know well. I don't need to cover that. We certify them for our enterprise customers, so they know, hey, this works on RHEL, and it works on Ubuntu, and it works on version 1404 and 1604. The container runtime is the piece that most people know of Docker, and it's really the most visible part of Docker when we talk about it as a developer tool. So most developers, when they download Docker, this is really the piece they interact with, is being able to spin up containers. And we've actually had the container runtime. We've actually renamed the open source project Moby, and the container runtime, Containerd, is now a part of that project. So this is the one that most of you probably know and have heard about and have seen in lots of blogs and lots of information about. Probably less well known is orchestration. Orchestration, we have an embedded orchestration system called Swarm. Orchestration is really two pieces in our minds. It's really the ability to connect all of the Docker hosts together. So any node or physical or virtual infrastructure that runs the Docker engine, the container runtime. If you take all of those together and cluster them together, so providing a layer of node management and aggregation of resources, as well as the ability to then deploy containers, networks, volumes across those hosts. So coordinating that information is really the two pieces of orchestration that we talk about today. There's a lot of distributed state that needs to be stored as a result of that. We have embedded inside Docker Swarm the ability to pull that distributed state into one place and provide a highly available distributed state store that you can use once you set up your cluster. Volumes network are key components of this. Docker volumes and lib network are the components that many of you are probably aware of. Those are Docker volumes allows you to actually create a kind of a primary resource that you can manage alongside the containers themselves. And then networks, of course, you can create these networks as you need to across your cluster, so that you can actually take your container with the network it needs to be on, and be able to use that across the cluster. All of those are pluggable components. So volumes allow you're allowed to use Docker plugins to back your volumes, so you can integrate that with your existing storage arrays and storage that you know and love. And similarly with networks, we have third-party providers who can provide those capabilities, and you can back those with, say, Cisco networks using the Contiv plugin, or other third parties who are out there who will do a lot of the back-end coordination of the networking for you. We have additional security functionality, and we'll talk about a lot of that in the next slides as we talk through the work with Kubernetes. Now, across the next row, you'll see a lot of additional functionality. The private image registry, our secure access and user management, application and cluster management, image security scanning, content trust, and policy management. A lot of these are the features that we build into the enterprise platform. So we take a lot of the primitives that you'll find here in this lower half, and we not only surface them up, but we simplify them and then fully integrate them so that you have a common user experience. You have integrations into your enterprise directory stores. You have the ability to define policies around how containers are managed in your system or who has access to them. And content trust so you can sign those containers and sign the images as they move through, say, your pipeline stages in your development process. So a lot of this is the work that we've done with our Enterprise Edition, building on, basically built into 2 products that ship as a part of that platform, Docker Trusted Registry and Universal Control Plane. Those are really the 2 products that get exposed to customers that provide this next set of functionality. And then at the top are other certified containers, plugins, and software that third parties can run on top of the Docker platform, and customers then know they've got full support all the way through. So that's just a quick overview of kind of all the pieces of the platform. So you notice, one of the key pieces here is orchestration, and everybody who knows Kubernetes knows that it's an orchestrator, right? This has really been, I think, one of the widely adopted and actually widely used capabilities out there, and everyone has at least heard about it. Certainly, when we talk to our customers, everyone's heard about Borg and the history of Borg and how Kubernetes was really styled in the, and developed from that as a starting point. We think orchestration is an important aspect of this entire platform. We think it's actually one of the key components that make a container platform possible and usable by enterprises. It's not the only component. And so when we thought about our embedded component with Swarm, and we thought about building it, we were focused really on how do we leverage all the value of the Docker runtime and expose that up with a very simple orchestration capability. And we will continue to enhance it and add to it. But look, we acknowledge, like the Google guys, they know a ton about orchestration. And so when they went off and built Kubernetes, they thought about everything they were going to need, because they've done it before. They thought about everything they were going to need with orchestration, and it's an incredibly feature-rich set of capabilities in Kubernetes. So when we thought about adding support for Kubernetes in our platform, it actually made a ton of sense, just from the perspective of it's well understood by customers. It's maybe not well understood, but actually it's well known in the container space, and it's a critical component to make this whole platform work. And so we were actually pretty excited to say, we can actually make this pluggable as a part of our enterprise offering, and that was these guys. Actually, I should have introduced Daniel Hilchin and Alex here from Docker. They're both here in the room as well with me. These are the guys that really started our Enterprise Edition and developed a lot of those capabilities. So when they started this work, they thought about the fact that we would have to make this capability pluggable. And so it was pretty easy for us to then consider Kubernetes as a pluggable component in the orchestration side of our platform. So why Kubernetes? I mean, we actually talked a lot about the fact that Kubernetes is well known out there. When we decided to make the addition of Kubernetes to the Enterprise Edition, there was 2 real things that we wanted to keep in mind. One was customers need the functionality, and so they're asking us specifically, hey, we want to be able to use the Kubernetes functionality, but we want to leverage all of the Docker platform to do so. So when we got asked about this functionality, that was one of the main drivers, was a lot of our existing customers and new customers who would say, we've made a choice to use Kubernetes, but we really still like a lot of the functionality you have. We love what you've done with your Enterprise Edition. We just need to have it be based on Kubernetes. So that was one piece. The other piece we heard was for folks that were already using Kubernetes, that there are some operational concerns. How do I manage this on a day-to-day basis? How do I tie all of the pieces together? Who's going to support me if I grab the latest open source project and deploy that at scale in my environment? Who's going to test for performance and scale and such? And so that's another place where we thought certainly we could offer value. The other place I'd add is, when we thought about Kubernetes experience, we thought about it from the developer all the way through to the operator. So it wasn't just, hey, let's make sure it works for enterprise IT. The other part of this announcement that we're going to be talking about is the developer experience in Docker for Mac and Docker for Windows, our desktop editions. So we're going to make Kubernetes an integral part of that experience as well, which means that every developer who gets Docker for Mac or Docker for Windows and is standing up Docker for the first time can also use it with Kubernetes. So they'll be able to use all the Docker tooling, compose, builds, etc. All of that can be done with a Kubernetes orchestrator behind it.
Very good. That would be great. I would so use that.
We know that's one of the real mainstays for Docker over the last year and a half has been just our adoption with
like Minikube, but for Docker for Mac.
Yeah, it's think of it as kube built into Docker for Mac and Docker for Windows. You don't even have to install it. You just as you upgrade to the next version of Docker for Mac or Windows, kube will be there, and it'll be your option to turn it on, and then you can use all of your existing tools, compose, obviously all the Docker run commands, all of that stuff just works, and it'll be backed by kube. Yeah. So that was really important for us. Is we know the heritage of Docker is really developer tooling. We've been making our way into the enterprise as an enterprise offering, so we wanted to make sure that experience was consistent across both. Now we've done this pluggability work before. I mean, this isn't the first time we've made something pluggable in the Docker universe. We did that with networks. We did it with volumes. So we've kind of learned our lessons in how we develop plugins and how we make those interfaces pluggable enough that we can swap components in and out. We actually added support for Windows and mainframe just in our last release of Docker Enterprise Edition as well. So now you can have a cluster built with Docker Swarm of Windows nodes, mainframe nodes, Linux x86 nodes, and you can have them completely intermingled amongst each other in the same cluster. You can use our access controls to separate who gets access to which ones, and you can make sure that your Linux x86 applications land on your Linux nodes and your Windows apps land on your Windows nodes, but you can manage them as if they were one big cluster and then bin pack as you need to on that cluster. So same thing is true with the orchestration side. You can now have a single cluster. That single cluster can have your Windows and mainframe nodes in them. And then for your Linux x86 nodes, you can decide whether you want to run kube or whether you want to run Swarm-based orchestration deployments on them, right? Now, technically, you can actually mix on the same nodes. So all Swarm nodes will be running kube as well. Now, we're telling customers for the purposes of production deployments, that's not a good idea, and I'll actually ask Daniel and Alex to explain why that is in just a minute. But all of the nodes that run Swarm, and we're leveraging Swarm to actually stand up the cluster, also run kubelet as well. So you'll be able to say, I want kube workloads and Swarm workloads on the same node if you wanted to. But again, for reasons of resource controls, we're telling customers for production use, you should separate those two. And there are access controls in the product that allow you to enforce that. So actually, maybe we'll take just a minute. I don't know if you want to explain kind of the how resource controls work with Swarm and kube, and then that might be an interesting sidebar.
So the issue is that both Kubernetes and Swarm think they own the entire capacity of the node for resources. So they will not actually track the usage of workloads created by the other orchestrator. Now, the problem there is that when you start reaching your node's capacity, both orchestrators will think that there's still space available on the node in both CPU, memory, and disk, and will happily provision more workloads there, which will lead to resource contention issues, meaning that the operating system's out-of-memory killer might come in and start killing some of your processes if your memory is overcommitted, or your CPU shares might get throttled equally across all your containers. So because of that, unless if you're very careful around how you share workloads with both orchestrators on the same node and you manually schedule things there, we recommend that you only use one orchestrator for production workloads. And we're going to have some basic primitives to allow you to select one orchestrator per node. And if there's no workloads, you can even change that.
But natively, any Swarm node would have kubelet. So if I'm just disciplined, I can just say kube on this one, Swarm on that one. But I don't have to administratively, I don't have to do anything to enable that. That can just be a back-end part of my operations to just say, designate these 5 nodes are kubelet nodes, these 5 are Swarm. Make sure you don't deploy Swarm to Cube, Cube to Swarm. But natively, the capability, the orchestrator will be available on each without having to have to go through and enable anything from a system administration perspective. Okay.
So how are you consolidating the Swarm interface through the CLI and kubectl and all the components?
Yeah, good question. So actually, it's almost like the next slide. So we're not going to try to mesh the concepts between the two. We actually want to make it clear that when you use Swarm, you use the Swarm API and the Docker API interface. When you use Kube, you use the Kube API interface. They're both controlled through access control and authorization, and that's common across the two. So Docker's the universal control plane will make sure that whoever's coming in is authenticated and authorized, but one API serves one and the other API serves the other. Now, having said that, we're taking Docker Compose as an example and allowing you to use that against either orchestrator. So Compose will actually be able to deploy against either Swarm and create Swarm services, or will actually allow you to say, I want to use this against Kubernetes and deploy Kubernetes pods and replicate.
It's like Phoenix from the ashes for Compose, or because Compose moved over to stack deploy, and Compose was unmaintained because it's Python. So what are you doing?
Yeah, so it's the stack deploy commands, right? So it's compose YAML is what we're talking about. Yeah, the Compose CLI itself. We're not gonna. Yeah, we're not making any changes to that.
Yeah, essentially, we're still working on what the exact CLI user experience will be like between switching, if you want to switch between Swarm deployment versus a Kubernetes deployment. But effectively, Docker Stack Deploy will now be able to target either the Kubernetes side of the cluster or the Swarm side of the cluster with the same Compose file. So what we've built is an extension into Kubernetes that understands the native Compose file format and then is able to spin up underlying Kubernetes resources based on the definitions inside of the Compose file.
I mean, Kubernetes already has a lot of ecosystem around deployments and templating. If you think about Helm and how that works, I've been working on a project that targets Swarm and Kubernetes, and the config management is so much easier with the tools in that ecosystem and community. So, how far are you going with it?
So as far as the Kubernetes ecosystem, you'll be able to use all of those tools.
With the Docker retrofit of talking to a Kubernetes cluster.
Well, yeah, so essentially, as Banjot mentioned, the full Kubernetes API is exposed in the stack. So essentially, Helm and other extensions that sit on top of the Kubernetes API will be able to operate directly against the system. So it's just you have choice. Yeah,
it's your choice, right? So what we want to do is not if folks have, and we've heard from enough folks who've said, look, we really like the Compose format. Our developers have been using Docker Compose. They don't really know what's on the other side, and they don't really care to. So for those folks, they can point at a kube cluster now, and it spins up kube nodes. But if you're a developer who's been using kubeyaml and you've been using Helm and you've really bought into that ecosystem, those work just as well. I mean, the entire Kube API is expressly available. Yeah. So one thing that we did that I think this is slightly different from what's available out there today is we wanted to make sure that when we integrated Kube, it wasn't just a kind of slap an orchestrator on the side and kind of call it a day. We spent a lot of time working out what that interface will look like and how the installation experience would look. And so what we tried to do when we first started Docker EE, we focused a lot on the installation experience. That was one area that we felt was expressly something that we could help with, especially when you need to tie in all the various components together. So in standing up actually Kube with Docker EE, we actually made it part of the installation process. So when you stand up Docker EE today, you start your first Docker Swarm, using Docker Swarm init, and you add nodes to that cluster. That can then have Docker EE installed, Universal Control Plane installed on it. Universal Control Plane will bring Kubernetes with it, and you don't have to do any additional work to actually have Kubernetes now running in that cluster. So what we'll do is we'll map Swarm managers to Kube masters. So all Kube masters are already mapped to the Swarm managers that are in place. So if you've set up high availability for your Swarm, that now maps to your Kubernetes deployment as well. and you don't actually have to do any node changes or additions or modifications for the cluster. You do that all through the existing Swarm APIs. And so we're leveraging Swarm where we think it really did a good job, which was standing up the cluster, doing it securely, standing up the certificate authority, setting up mutual TLS, doing all the certificate rotation, doing cryptographic node identity with certificates on each node, and then that's taken care of by Swarm. So all the cluster management is done for you with Swarm, or I should say that's done with Swarm in mind, and then you use Kubernetes really as just the interface to deploy your containers on that environment. So we think that actually simplifies a lot of the stand-up experience around Kubernetes, and that actually makes it really, really simple for any enterprise who already has Swarm or has been using Docker EE to now stand up Kubernetes on that same cluster.
So for those of us in enterprise that aren't necessarily familiar with Swarm versus Kubernetes, what the install experience is I think is a big deal by itself. Is there any enterprise operations team efficiencies that Swarm brings to Kubernetes that wasn't there before? Because one of the big things about Kube is that, we don't want to touch it. We don't want to manage it. Right. So is this kind of a set it and forget it type of thing? If I maintain Swarm and I focus on maintaining Swarm, I inherently maintain Kube? Or is there still parts of Kube that I need to care and feed?
No, that's exactly the intention, is if you are carrying and maintaining Swarm and you've set up your availability through Swarm, you're adding your nodes and removing nodes through Swarm, then Kubernetes follows. All of that is just passed right to Kubernetes. You don't have to worry about actually doing any additional work for node management with Kubernetes.
So from a capability perspective, is it mainly, so I get the enterprise friendliness of Swarm. I get Kube APIs. Kube from a orchestrator perspective is, so I'm still looking at this from an enterprise perspective, operations perspective. Developers have asked me for Kubernetes APIs. Let's say that I was perfectly happy with Swarm orchestration and resource management, but I was asked for Kubernetes APIs is the use case that I can see. Is there a point where I need to worry about conflicting opinions of orchestration management with the way that Swarm manages the overall cluster and the way Kubernetes wants to be consumed?
I don't believe so. I'm going to defer to I don't believe there's anything that would conflict in those operations. But Daniel, I'll let you.
In general, the APIs are not conflicting. So essentially, the UCP will expose the full set of APIs for Docker APIs and the full set of APIs for Kubernetes APIs. So all of the Kubernetes tools and ecosystem components that your developers in your environment are familiar with would operate against the endpoint that makes up UCP. What you can do, as we discussed from a resource contention standpoint, as an operator, you can choose to segregate a set of nodes for running the Kubernetes workloads versus a set of nodes for running the Swarm workloads. So you have that level of control at an operator standpoint. And so then your developers that are deploying into the environment don't have to think about it. They just deploy workloads, and they'll schedule onto the nodes that you pre-selected.
And then I have a single, and excuse the lack of familiar terminology, but I have a kube master. So I have a kube master for the cluster. So, and that kube master is also a swarm master, or whatever the terminology for swarm is. Right. So from a multi-node orchestration bit, I have cluster nodes, and just there's no conflict of resources for those two separate trees. So the cube trees has its nodes. Yeah. So let's say I have a 6-node cluster overall. 3 nodes are dedicated to Kube, 3 nodes to Swarm, and then whatever overhead. There's the Kube sees this total of, Kube should see a total of 6 nodes. Swarm sees a total of 6, but I'm only deploying to 3.
That's right. That's right.
So it's the methodology to deploying to 3 that I'm not clear on, but that's another, like,
Yeah, so maybe let's just kind of clarify a few points in there. So yeah, so every Swarm manager will also be, every Swarm master will also be a Kubernetes manager. So those constructs are kept consistent. So as long as you've decided which nodes you want to be your manager nodes, all of the highly available components for managing both stacks are present. So you can kind of think of that as your infrastructure control plane of the stack. And then for all of the worker nodes, they are all capable of running workloads from both orchestrators. And it is up to you as an operator to decide how you want to partition that.
So it is not it's not a developer level decision. This is an operator level decision to say that, oh, this manager has 3 nodes dedicated to it. This master has 3 nodes dedicated to it. So from a developer perspective, I'm just pushing code up to my Kube API or my Swarm API.
Now, you may have developers that want to fine-tune which nodes they land on, and so they can use scheduler hints to Kubernetes to choose which nodes their workloads land on. But ultimately, as an operator, you can partition it or decide which orchestrator is allowed to schedule on those nodes.
Yeah, that segregation becomes an operator's control. And then the choice, if you give them access to both Swarm nodes and Kube nodes, then they do have choices then. Yeah. Cool. So far, so good. Any questions on the makeup? So one thing I want to make sure is clear. Like on the cluster management side, we enforce one way of managing the cluster with Swarm, and then on the container orchestration side, you've got your options of Swarm and Kubernetes. Now, the other work that we're doing, and actually this really only covers 2/3 of the work we're doing. The other work we've been doing is Docker for Mac and Docker for Windows. And so we're going to be embedding Kube as a part of the deployment of Docker for Mac and Docker for Windows natively, as a part of your installation process. So now when you upgrade to the next version of Docker for Mac, you'll have Kube running there automatically in the background. Whether you choose to use it or not is entirely up to each developer. So again, developers get the choice of being able to deploy locally to Swarm or deploy locally to Kube, and that's entirely up to them. Now it's a 1-node cluster, so be careful there. You'll only have 1 node to play with.
Memory-wise, Kubernetes is pretty greedy, and it's a really large distribution, so that's going to affect your download size quite dramatically. But also, I don't know what your implementation is, but I assume, do you have 2 Hyperkit VMs, one with a Swarm node running and one with Kubernetes, or are you bundling all into one?
We're talking in the context of CE right now, correct? Yeah. So for the desktop edition, it is 1 Hyperkit VM or 1 InfraKit VM, and it's running all of the Kubernetes components in containers on top of that. We use the Hyperkube image, so essentially it's 1 stripped-down image that has all of the components necessary to run it, and it is a optional feature, so you can choose to enable it or not enable it. As far as like memory and CPU impact.
Master, so that it can run containers. Yeah. Right. Yeah. Okay.
So I think the nice thing is, if you've got folks that are already kind of bought into Kube, that are using Kube, this gives them an easy way to stand that up locally. And then of course, you've got the availability of that in your enterprise and your kind of enterprise edition that your IT operations team might be running as well. So you guys are probably familiar with Docker for Mac and Docker for Windows, but this tool, we've seen just amazing growth in this tool over the last year. We started with over 500,000 folks using the tool when we first came out of beta. It's more than quadrupled since then. So it's huge adoption. We've seen it both inside enterprises, individual hobbyists, developers, small companies. We've got a whole array of folks that are using this set of capabilities. So nothing new to do here. The install works, and you just kind of continue using Docker for Mac as the way you want to, and then you have the option of turning on Kube or not.
Is the still the limitations on operating system still there for Docker? So I think the Windows 10 edition, you had to have the anniversary update.
Yeah, so that is still a limitation in that you have to have Windows 10 to be able to run Docker for Windows.
Specifically the anniversary update, or
I believe so, yeah.
So one other thing I wanted to call out was, we did a lot of work with our Enterprise Edition to add functionality and feature set that we think enterprises really can take advantage of. A couple of them we're going to call out here. So image management with Docker Trusted Registry, this all works natively with kube. There's kind of nothing additional you have to do to make sure that your Docker trusted registry, which has scanning and signing built into it, nothing additional that you have to do to make sure it works with your kube-based orchestration on the operation side, on the runtime side. So that stuff will work natively. Nothing additional you have to do there. All of the policy-based promotion works. So we added a number of features in our last release with EE 1706 that allows you to set up promotion from repository to repository inside Docker Trusted Registry. So you can actually define different repositories and the policies that define the gates to go from one repository to another. So if you have a developer repository, individual developers have their own, then you might have a centralized kind of QA repository. You can define a promotion policy for individual developer repos into the QA repo.
And this is just taking Docker EE concepts and extending them into Kubernetes so this is again from operators and CI/CD perspective that, I can promote code and images from one landscape to another landscape until it eventually reaches production, until it eventually,
Yeah, until it reaches the kind of kube cluster itself. Yeah, so that functionality exists today in Trusted Registry. And so no difference in what you do there today versus what you'll do tomorrow. The image still lands on a Kubernetes cluster. You can use it just fine there as well.
This just brings discipline to Kubernetes itself, using that as a platform.
Yeah, and we've seen this with a lot of our customers already. They've been using Trusted Registry alongside Kubernetes and other orchestrators. So that functionality has already been benefiting them. For those that have been doing it alongside Kubernetes, there's a nice advantage now in that there's one throat to choke from one vendor for both the Trusted Registry as well as the runtime operations. Any comments about the Trusted Registry stuff? Any additional? Yeah, that's all. Those are all kind of straightforward. Everything else that you see here, we're leveraging again a lot of the Swarm functionality to identify and authenticate nodes. So you've got cryptographic identity for each of those nodes, which allows you then mutual TLS between all nodes in the cluster. That's all done via standing up with Swarm. And then lastly, the big part about this, from our perspective, is for most customers who are adopting any sort of orchestration platform, any runtime platform, they're being very wary of where which infrastructure they land on, what operating system they go to, what cloud provider they go to. Everybody's worried about lock-in, right? I don't think there's a single enterprise customer we've talked to who's not worried about this. If we go into, this enterprise application, or we go into this operating system, or we go to this cloud provider, we want to make sure we're not locked in. And that's really been one of the reasons that Docker itself has been something they've been excited about for the last few years. So similarly, with all of this functionality, we're making sure that we certify this against every cloud provider out there, every operating system that enterprises are using, commercial operating systems they use. So you're going to see us take our Enterprise Edition, already today available on AWS, on Azure. You can put it on physical or virtual servers running RHEL or Ubuntu or Oracle. We're going to continue that path. So Kubernetes is going to have the same availability. Nothing about that changes, which then allows you to have that consistent experience. If you're going to use Kubernetes on Google Cloud, and you're going to use it on-prem with your RHEL-based distributions, or you're going to use Azure also, you'll have that commonality across all three of them. So you'll be able to operate them, manage them all in the same way. And that was important for us to be able to make sure customers feel that consistency across their experience of a container platform, no matter where it lands. All right, I think that's really all I had from a slides perspective. Maybe we'll just pause and take questions or any feedback. What do you guys think?
So, not completely the space of that plan, but it's a surprise, and a good surprise. I think it's a needed thing. The ability to give customers as many options as possible. I'm putting back on my enterprise architect hat and thinking through if a company like Rail came in and said, hey, not only am I going to give you Kubernetes, but I'm going to give you a whole PaaS on top of that, the value of going into that, Rail is an open source company, but that's a locked-in solution. That locked-in solution that gives me an end-to-end, not only Kubernetes experience, but also gives me a PaaS on top of that, where you guys kind of say, you know what, you operate at a lower level than that at times, and equal to that. I'm trying to think what scenario would I choose Swarm over a Redshift or some other Kubernetes distribution?
Yeah, it's a good question, and one we actually we thought about a lot is, okay, so why use this over OpenShift or something else? To us, there's a big difference between operating a PaaS versus operating what we call our container platform, and we think that difference is what makes or breaks most operations teams. In that, for a PaaS environment, you have a very different set of tooling, a different developer experience, which could be beneficial, but a very different set of tooling and capabilities around how you can manage that in an operations world from what you can do with, say, this. For us, it was important that a lot of your visibility that operators have into the existing environment, into what's running into that environment, with containers, you get net additional visibility. You get more visibility to what's happening. So actually, if you compare kind of PaaS on one side and VMs on the other side, right? VMs, you knew something was running, but you just didn't know what was in the box, right? The VM itself was somewhat opaque. It was actually very opaque. Operating system in there. There's a lot of things going on in that virtual machine. On the PaaS side, it's almost impossible to know how to connect the project that you created in OpenShift down to the individual containers that actually run, and do you actually have visibility to those containers, and can you use your same operational tools to actually interact with that environment? We want to sit right in the middle. This is kind of our Goldilocks story. A little too hot, a little too cold. We're kind of right there in the middle. For us, we think it's important that developers get the choice and freedom they want. They get the experience of deploying as they want to, as they need to. And there's a huge ecosystem of folks that have developed container images, compose files. All of that ecosystem has really come to bear on Docker. But on the operator side, you get to now have much greater visibility to what application is actually running. Not just kind of here's this huge operating system and then there's like five things running in that VM. Now you can actually see the discrete containers and see what's actually running, what networks it needs, and you have visibility to all of that. You can take all of your monitoring tools, your logging tools, you get the advantages of all of those with that environment versus what you'd have to do in, say, OpenShift or in a PaaS. So we think the PaaS, the view of PaaS for us was it's a little too locked down. Even on the developer side, you have to choose which app frameworks you want to use and what's supported in that PaaS. For us, the container is the container is the container. You can put anything in the container. The other side of the equation, the operator gets to see what you're putting in. They get scanning and visibility into that container. They get to see what networks and what ports you've exposed. So they know what you're running now. And there's a lot more commonality in how they view the world than in, I think, any of the other kind of methodologies.
So depending on going higher up the stack, depending on your methodology, I can say, you know what, if I'm a container shop, go out to the Docker registry, get the microservices you need, and bring the images that you need to build the microservices that you need. Versus there can be a little bit more work and in some cases inefficiency. So this is a philosophy thing for the developer. I can go out and build the development platform that I want, just based off of the public registry and going to get SAML and whatever past features that I want to build my application with, versus having a very descriptive process like a Cloud Foundry or a or a OpenShift or whatever Rails solution is called, and having kind of that canned experience brought to you. Then as you move down to the operator's view, if you've selected this bring your own pass type of view or bring your own microservices view, then the operator has complete visibility. If the pass view has been selected, then you have less visibility, but developers have less upfront work to do, is the overall decision tree.
Yeah, and then I think for us the two big points that I would make to any enterprise who's trying to make that decision is, what about your Windows apps? So for us, Windows is a native container experience. It works inside Swarm just like Linux does, mainframe apps as well. So the heterogeneity of what we can support in that. And then I think the second one is, do you want your traditional enterprise apps and your microservices going through two very different software delivery pipelines or one common one?
And it's not just delivery. So even putting back my ops hat on, the Docker philosophy of containerize your apps first. If you choose to containerize your app instead of modernize it, you can containerize it and run it on the same orchestrator in theory and practice, alongside of your more cloud native applications. All the net new stuff is running side by side, and you can run your data center as a single data center with a single operating view versus the pass of I have to create this bimodal operating model all the way from development all the way to the operation side.
Just in different silo, we had Windows and Linux silos, we've had mainframe and x86 silos. That we feel like the PaaS model just creates yet another silo. And if you can say every app is managed the same way, Docker start, Docker stop, your apps all exactly the same, whether they're microservices or not. If you can deploy them all in the same way and you have the same ability to control what's in the application, use the same policies through the development process using image scanning and policy promotion type functionality for traditional apps as well as microservices, we think that's a huge efficiency benefit for enterprise customers to not have to worry about, okay, I need some tools here, I need some tools here. Okay, when I go here, I got to use this tool. When I use here, I got to use this tool, and we do things entirely differently.
I'm a relative beginner in the container world. I did something, attended a course, but still I would consider myself a real beginner. So VMware announced recently also some pivotal container Kubernetes services and so on. And can you elaborate a little bit on how your stuff relates to what they do? Is it competition? Does it integrate? Because VMware also, I think, dropped the Photon platform that didn't work out. They're still running their vSphere integrated containers. And a good friend of mine who's an analyst in the US, he's in touch with the Docker team all the time. He said that Docker was not overly happy with what VMware is doing. VMware is not exposing the full API and stuff like this. But I still would like to understand how it relates to it.
Yeah, and I would say that certainly the VIC, VMware or vSphere integrated containers, one problem is right away that it doesn't expose the Docker API. It is not actually using what is today the upstream Moby project. And so
They're rogue distributions.
Yeah, it's a rogue distribution that doesn't expose the functionality. I don't know if Daniel or Alex want to comment on. Yeah, we've certainly been in communication with them about it. We'd love for them to use kind of proper Docker in there, but
That would also mean that they have to pay license costs or something like that.
no, not necessarily. I mean, that's why the Containerd platform exists. That's why the Moby project exists. Is we want to standardize it, across the industry, and we submitted Containerd to CNCF for that purpose, so that we would have a reference implementation everybody could use. So I think that the Docker experience is one that we're very proud of because it's one we feel like is powerful yet simple enough to start with, and I think that's what didn't come through in VIC. That didn't happen. PKS I'm a little less familiar with. I know it's a Kubernetes-based distribution. I know it's Pivotal running on top. To be honest, I don't know much more than that. So but
I think it's probably not out yet or something. I'm not even
it's
sure
not
if it's
available
out.
yet.
The thing called Kubo, which uses Bosch.
Yeah, I think that's
Is that
it.
what it is?
I believe so, yeah.
Because they used to need 31 VMs to run that thing.
31.
Yeah.
And I don't know if it's as big anymore, but I think it's still
For dev, you can get away with 4, but you need 31 in production.
Okay, so it's a huge environment, basically.
Yeah.
And I think the other value add is that it's bringing the PaaS to easy way. So I was at VMworld, and the way that I understood it was that you're bringing the Cloud Foundry, specifically Pivotal's PaaS, to vSphere, so you get a easy to consume PaaS based off of containers managed by Kubernetes. That's the marketing slide of it. So
Right.
technically,
So I guess the question is, does the Kubernetes ecosystem work on top of that, right? That's
You asked the question, didn't you, when you finished your presentation, so what do you guys think of this? And, I think I made my mind up at the beginning.
yeah.
It's the right thing.
Okay.
And this seems to be the bandwagon that everybody is getting on at the moment, is to provide a Kubernetes API. What I'm excited about that's different here is the Docker for Mac experience. So I'm maintaining quite a popular open source project that targets Docker Swarm, and originally I only targeted that, and then moved to support Kubernetes as well, and I was surprised how similar they are at an API level.
Yeah.
But I have to maintain 2 sets of documentation, I have to maintain 2 sets of config,
Yeah.
I have to tell people how to install Minikube, and if not Minikube, which doesn't have RBAC, I don't know if you have RBAC,
Right.
then you have to have another set of instructions, and have maintainers that only know Swarm and ones that only know Kubernetes. I think this will democratize it, and it's going to help spread Kubernetes, whether that's what you intended to or not. But it's going to make my life a lot easier. And at ADP, we have teams that are deploying, as you know, with EE,
Yep.
enterprise architecture. But I had people get in touch, and they said, we want to do a research project into Kubernetes, we want to get it authorized to run it. And I think this is what's going to allow teams like that to really be able to go where they need to go.
Yeah. Yeah.
And I'm excited about having to maintain less configuration files. Yeah. I don't know what the flavour is going to be like. I know Docker always has a very opinionated way of doing things. So it'd be great to see how that plays out.
Yeah. Great. Any other feedback? Well, thank you for that. I think, I think you said it just right. We're hoping to democratize the ability to use orchestration. Swarm, Kubernetes, I think it's great. Like we would rather the industry start to develop commonality across that, and we've actually seen as we've developed Compose and made it work on Kubernetes how similar these things really are, and I think that's great for the industry as a whole. I think it'll help every organization, ADP and even those much smaller than ADP, be able to stand up a container platform much more easily.
So Windows containers, I assume that this is running on Containerd, is it? Or is it running on Docker, is it?
It's running on Docker.
So
Yeah.
Does that mean Windows is in, or?
So Windows containers work with Swarm, and then when the Containerd work, and I think even support for Windows containers in Kubernetes, I think is not quite GA yet, even in 1.8.
So you're not kind of.
We're not gonna support it, we're not gonna finish that off yet. We're certainly gonna work with the community to help finish it off.
Right.
But yeah, we didn't try to finish it off for this release.
It's all under embargo and hush-hush, and looking forward to tomorrow, but what engagement have you had with the CNCF? And are you making use of any other open source projects from the Kubernetes community in this solution?
Yeah, maybe I don't know what other.
Yeah, so I'm not in the loop on
Projects.
the CNCF part, so
Yeah, the
need someone else
CNCF
to answer that part.
Yeah, that may be. Maybe we can come back.
So yeah, Kubernetes is basically belongs to the CNCF,
Yeah.
right? That's its home, and I would have thought there should be some, there would have been some kind of engagement there.
So we've certainly submitted stuff to the CNCF. Solomon is I believe a board member on the CNCF. So yeah, I'm sure those conversations are happening. What I don't know is what parts and what projects of beyond Kubernetes we're using out of CNCF. But we've submitted Containerd to CNCF. So and Notary actually was submitted just recently as awaiting approval on CNCF.